Good morning, everybody. This is Mr. Young, and we are here for our first remote learning lesson. And this week we're going to talk about arithmetic sequences and series. I hope you guys looked over the material the last 2 weeks. But let's get started. Arithmetic sequences and series. Well, first of all, let's see what we're going to be learning today. We're going to learn how to identify an arithmetic sequence and find the value of a term. And we're also going to learn how to write the explicit and recursive forms of an arithmetic sequence. So there are 2 ways to represent those algebraically, and we're going to check those out. And we're also going to see how to find the sum of an arithmetic series. So if I want to sum a certain number of terms in a sequence, then we're going to add those up, and when you add up those terms, that's called a series, and we're going to see how to calculate the value of that. What is an arithmetic sequence? Well, a sequence itself is a pattern, is a list of numbers. It could be represented numerically, it could be a geometric representation, but a sequence is just a progression that follows a certain pattern, while an arithmetic sequence is a pattern of numbers that increase or decrease at a constant amount, or a constant rate, or by a constant value. We call that value the common difference, which is right here. In this particular progression that's given, these are your even numbers, 2, 4, 6, 8, 10, and 12. You thought I was going to say, who do we appreciate, right? I know you. Okay, 2 to 4. How do we get from the first term to the second term? Well, I can do that by adding 2. And then from 4 to 6, I'm going to add 2 again. 6 to 8, I'm going to add 2 again. 8 to 10, add 2 again. 10 to 12, add 2. So we know, because every single term progresses by adding 2 to the previous term, that they all have a common difference, and that value is the same for every single pair of terms that are in succession. And so we know by definition this is an arithmetic sequence. So how do we identify an arithmetic sequence? Well, just like we saw, we're going to look at, and forgive my cough, we're going to look at how this progresses. So we're going to start at the first term. And the way you get the difference is just take the second term and subtract the first term. So we're looking from here to here, and we're really just going to do 7 minus 2, which is a positive 5. And then right here from 7 to 12, I can add 5 also, because 7 plus 5 is 12. Or I can say 12 minus 7 and then get 5. Same thing here, I have 12 to 17. Well, I arrive at by adding 5 to 12. And then 17, if I add 5, that's also gives me 22. So we know, since every single term here has a common difference, and that common difference we call D, is equal to a positive 5. That means that, yes, this sequence is arithmetic. Okay? So that's how you can identify an arithmetic sequence. Now, you do not want to check the common difference just between the first and second term, second and third term. You're like, yeah, it's plus 5. Because what if this last number were 23? Well, 17 plus 5 is only 22, so that would no longer represent an arithmetic sequence. So for everything given, you need to check to make sure you indeed have a common difference between every successive term and the previous term. So don't leave anything out. Check all of them, okay? So if I'm looking at a sequence, I may want to figure out what another term in the sequence is. And if you look at the last one right here, if I wanted to know the next term, well, that's easy, y'all. All I got to do is say plus 5, and I get 27. If I do plus 5 again, what do I get? Come on now. I get a 32, and so on and so forth. But what if I'm sorry. What if I asked you, what is the 25th term? Do I want to keep adding 5s over and over? What about the 100th term or the 200th term? How would you calculate that? I wouldn't want to keep adding 5 that many times. That would be just a pain. So we have a nice formula, which we call the explicit formula. And it's explicit because it's written out in terms of the term number, okay? So when we talk about a sequence, I'm going to switch back. This right here, I'm going to write this in green. This is my first term. This is my second term. This is my third term. This is my fourth term, my fifth term. So every single term in this sequence has a number, and typically we'll refer to that as n equal 1, n equal 2, n equal 3, n equal 4, n equal 5, and so on and so forth. So when we talk about finding the 25th term, well, I'd want to know what term is associated with n equal to 25, okay? Now in this formula, this a sub 1, that is the first term in the sequence. So that's your starting point. The n is the term number, and d is the common difference. So, I'm sorry. So if you know what your first term is and you know the common difference, you can write the explicit formula. Okay? So here, we want to find the 50th term for the given sequence. Well, to do that, I want to start out by writing the explicit formula. A sub n equals a sub 1 plus m minus 1 times d. Now, I will tell you this, guys, because I saw this online the other day. I thought it was kind of cool because we've typically referred to this as a sub n, but some people will talk about a Tn equation. And a Tn equation, well, that's the same thing as a sub n. It's just that t represents term, so the nth term. And I kind of like that notation better, but just for sake of this, we'll stick with a sub n right now. But if you ever see that and you hear someone say Tn equation, that's what they're talking about. So anyways, if I want to know what my first term is, I come over to this sequence, and it is this number sitting right there. That's our starting point. So we know a sub 1 is equal to 2. And the other piece of information we need is that common difference. So I need to know if I'm going from 2 to 7, what is that? Well, we found a while ago that that's a plus 5, right? From 7 to 12, well, that was a plus 5. 12 to 17, plus 5. And 17 to 22 was a plus 5. So if this were a brand new sequence, I'd check all of those just like I did. And now I know that D is equal to a positive 5. So now I can write the explicit form of this sequence as a sub n equals our first term 2 plus m minus 1 times a positive 5. Now, you may see this written as 2 plus 5 times n minus 1, but typically we'll also simplify that. So we'll actually multiply the 5 into the quantity n minus 1 by doing distributive property, and you'll get 2 plus 5n minus 5, and then you get a sub n equal to, well, you have 5n here, and then 2 minus 5 is just a negative 3. So a sub n is equal to 5n minus 3, and this right here, guys, right here, I'm going to try and box it in. This is your explicit formula. All right. So now the last thing they wanted you to do, they want you to find the 50th term. So we're going to look at the term associated with n equal to 50. And to do that, all I have to do is look at a sub 50. So we're looking at n equal to 50, and I plug into our explicit formula 5 times 50 and then minus 3. Okay? So now I get a sub 50 is just equal to 5 times 5 is 25. Oh, sorry, guys. Lost my place. I did that earlier with my other class. 5 times 50 is just 5 times 5 is 25 and add a 0. And then subtract 3. So a sub 50 is equal to what? Well, 250 minus 3 is just 247. Okay? And then that is our final answer. And we'll box that in. All right? So that's easy, guys. You have to know the formula, though. You must know this formula right here, the explicit form. If you know that explicit form, then you know exactly what to do. Now, there are sometimes they'll give you the 50th term, and maybe they want to find out the common difference. So they'll give you the first term, they'll give you the 50th term, and, well, you know n is equal to 50, and then you have to calculate the d, okay? So there's all sorts of things you can do with that formula, and, you know, if you remember, equations are not just going one direction across the equal sign, they go both ways, okay? If I had area equals length times width, well, I could have a problem where I'm given length and width and calculate area, or I could be given area and length and asked to calculate the width. So again, equations work like that. But if you know that general form for the explicit formula, you're good to go. All right? All right, so, wow. Trying to change the color here. There it goes. The recursive form for an arithmetic sequence. Okay, guys? This is not hard. Okay? Not hard at all. We already know for this sequence, because it's the same one from earlier, that d is equal to 5, our common difference. Okay? Now, the recursive formula, another way to state it is that you're doing the next term is equal to the now term, the current term, plus your common difference. Because that's what you're doing to progress between each term, is just simply add the common difference. Okay, sometimes the common difference is negative, so you'd be subtracting a number. But in this case, you can write it as next now if you like. But this right here is the formula we're looking at. And it is just a sub n equals the previous term, which we say a sub n minus 1. Okay. And then plus d, well, in our case, we have plus 5. That is the recursive form. I bet you guys thought that was hard when you heard the word earlier, didn't you? Well, it's okay. You don't have to admit it, but it's easy, okay? It's that simple form. So you need to know that form, and then you can easily write recursive form. All you need is the common difference. Now, there's another way to write this, guys. And so if you see it written like this, it's the same thing. But I could say my next term is n plus 1, and then a sub n be the current term. Oh, sorry, guys. Did it again. And then a sub n plus 1 equals a sub n plus 5. So that is the exact same thing. Okay, these are the same. All right. All right, so let's move on. I want you guys to try this one. Okay? I want you to try it. I want you to pause the video. And when you're ready, continue to check your work. Okay? So what you're doing, you're given this particular sequence. You want to know, is it arithmetic? Okay, so check that first, and I'll tell you it should be if I did my thinking properly. Then the explicit form of the equation, you're going to write that out. You're going to write the recursive form, and you're going to calculate the 30th term. And I'll give you a hint. Remember, these two are tied together. Okay, once you know the explicit form, you can find the 30th term. Okay? So pause the video now, and when you're ready, continue on, and we'll check your answer. Okay? All right, guys, how'd you do? Let's find out. Okay? So first thing, we're going to look at our given sequence, and we need to know, is this arithmetic? So if I move between 54 and 51, what do we have to do? Well, I had to subtract 3. If I move from 51 to 48, what do we do? Well, I subtracted 3 again. And if I move 48 to 45, I again subtracted 3. So in this case, the common difference is a negative 3. Okay? Our first term, in this case, is that first number, that 54. So the explicit form of the equation, if you remember the formula, it's just a sub n equals a sub 1 plus n minus 1 times d. So we're going to plug in what we know. A sub n equals a sub 1 is 54 plus m minus 1 times a negative 3, okay, which is our d. Now we want to simplify this, so we're going to say a sub n equals 54, we're not touching yet. We have a negative 3 times a positive n, that is a negative 3n. And a negative 3 times negative 1 is a positive 3. So a sub n is equal to 54 plus 3 is going to be our 57 minus 3n. So that is your answer for A. Now the recursive form we said was easy. It's just a sub n equals a sub n minus 1 plus our common difference, which in this case is negative. So we're going to get a sub n equals a sub n minus 1 minus 3. And that right there is your answer for B. All right. The 30th term. Well, again, we're going to go back to a sub n, okay? So we're going to say a sub 30 is equal to 57 minus 3 times 30. So that is just 57 minus 90. Now, guys, I'm not good with doing that in my head, so I'm going to come over to the side. I don't have my calculator, so I'm going to, well, I have a calculator on the tablet here, but why bother to find it? Let's just subtract this real quick, okay? So this is a 10, that's an 8. 10 minus 7 is 3, and 8 minus 5 is 3. So 33, and that's going to be negative. So a sub 30 is equal to a negative 33. And that is your answer for C. All right. So again, it's not hard. I'll reiterate, you have to know this formula, so memorize that. You need to know your form of the recursive. Again, if you do, it's easy to write. The only thing you need is that common difference, and you're good to go. And then a sub 30. Now, guys, I guess I made a slight boo-boo On the recursive form, you probably do want to specify your first term, okay? Now, I could have any sequence that progresses according to a common difference of -3, but I don't have this particular sequence until I specify the first term. So I should have pointed that out earlier, and I didn't, so I apologize. But definitely write down what the first term is. And then again, I can use the explicit form to calculate the value of the 30th term by simply plugging in n equal to 30. Okay? So let's move on. What if we need to sum a finite number of terms? Okay, well, we can do that. Okay. So an arithmetic series is a sum of an arithmetic sequence. So we're adding up the terms in the sequence. So there are certain formulas we can use. I typically will do this one, okay, this first one. There is a second representation if you guys want to play around with that. You might even take it as a project to show that those two are indeed equivalent. But it's the same notation. A sub 1 is your first term. A sub n is the nth term. N is the number of terms. And D is your common difference. Okay? So we need that formula. I will tell you on the testing at the end of the course that particular formula is given to you. Okay? AFM has a formula sheet, so that particular formula is on there. So let's look at this problem. It says find the sum of the first 20 terms. Okay? Well, first of all, there are other types of sequences. So I hope you guys are thinking, hey, I got to find out what type of sequence this is. Well, if you notice, it's the same sequence from earlier. But again, you would want to check that this is indeed an arithmetic sequence, because you're going to check these differences and make sure they are all the same. So in this case, it does have a common difference of +5. I can say this is arithmetic. And that means I can use this formula for the arithmetic sum. Now I want you to look. This formula requires certain things. If I'm going to sum S of 20, I need my value of n. So this requires n equal. It requires a sub 1 and it requires a sub n. Okay? So I need all of these. I can't do the sum until I have all this information. Now, what do we know? Okay, we know that n is equal to 20 because they said sum the first 20 terms. Our a sub 1 is given over here. That's just a 2. But a sub n, well, we need to know what that is also. How do we get a sub n? Exactly, I hope you're thinking the same thing. You have a sub n equals a sub 1 plus n minus 1 times d. So we're going to plug in everything that we know. A sub 1 is equal to 2. N is equal to 20. And d is equal to 5. So we're going to multiply this out. So I have 2 plus 19 times 5. Wow, that's not very pretty, is it? Well, guys, I'm going to show you how to do some mental math. Okay, this is how I would do this. I split this apart. This 19, if you write that as 10 plus 9, and then multiply by the 5, and again, this is what I do in my head, guys. This is mental math. I'm just writing it out. But 5 times 10 is 50. 5 times 9 is 45. And then you add them together. Well, that's just 95. So 2 plus 95 is just 97. So our a sub n is 97 up here. Okay? So do we have everything? We have our n equal to 20. We have a sub 1 equal to 2. We have a sub n equal to 97. So guess what? We can plug everything into this formula. So s sub n, and we're looking at s or n equal to 20. So this is s sub 20 equals n is 20 times a sub 1 is 2 plus our 97 divided by what? Divided by 2. And it looks like, I don't know if this is going to work out nice, but don't worry about that. I always tell my students, simplify before you multiply. This 2 will divide into 20. 2 into 20 is just 10. So right now you get 10 times 97 plus 2 is 99. So this is just 990. So s sub 20 is simply 990. And you're done. Okay? So again, you need to go through, determine if your sequence given is arithmetic. Sometimes you're told it's arithmetic, and I can skip that step. But if I'm doing a mixed set of problems, because later in the week we're doing geometric series, you're going to need to determine what type series it is. Okay? And then once you know that it's arithmetic, then I'm going to use the appropriate sum formula, which is s sub n equals n times the quantity a sub 1 plus a sub n divided by 2. I gather my information, n equal to 20, a sub 1 equal to 2. The a sub n I have to calculate in this case, because I'm not told it. And once I know it, I plug everything into the formula and just simplify. Okay? So very straightforward. Now, how do we find this sum? Well, I want to first determine, what did we say? Is it arithmetic? Okay, we're not told that it's arithmetic, so we better double check. So look at the common difference. 1 to 5. Well, I got there with a plus 4. And guys, we're talking about the sequence. So if I'm looking at 1, 5, 9, on and on up to 49, 53, I want to make sure that each of those progressed by a common difference. So 5 to 9 was a plus 4. And check these two also, because that's also part of this sequence. So we got 49, 53. Well, that's also a plus 4. So our common difference is 4. Therefore, it is arithmetic. By the way, guys, these 3 dots right here, if you've never seen that before, it means therefore. Okay? It's an easy way to write therefore if you're taking notes. All right? So now, we know it's arithmetic. We know our sum formula. Do you recall it? F sub n equals n times a sub 1 plus a sub n divided by 2. Well, let's see what we know and what we don't know. Okay? So first of all, I need my n. Okay, so I'm going to start writing this out. N is equal to, I can't count up the number of terms here because I have this break, this dot, dot, dot. So that would be our unknown right now. So I'm going to have to find that somehow. Then I have a sub 1. Well, that's easy. That's just 1. You see our first term right there. And then I have a sub n. Well, I do know what a sub n is. That's the last term. So that's our 53. Right? So all I have to do is find out what's n. Okay? Well, I hope you guys recall our formula is a sub n equals a sub 1 plus n minus 1 times d. Well, we know our d up there is 4, and I know a sub n and a sub 1, so that leaves me n to calculate. So all I have to do is substitute everything that I know. A sub n, we said, is 53. A sub 1 is equal to 1, plus n minus 1 times d is 4. Now to solve this, I want to get n minus 1 by itself. And I'm not going to worry about distributing right now. I don't care about doing that right now. You can do that if you like. But I'm going to go ahead and say 53 minus 1 on both sides. And that's going to give me a 52 is equal to n minus 1 times 4. Okay. And then what do I do from there? Well, I'm going to say, hey, let's divide by 4 on both sides. That's going to cancel and give me n minus 1 equal to something. Well, I can come over to the side and do that. We'll do 4. Y'all remember long division, don't you? I don't have my calculator, right? So I'm doing it the hard way. 4 into 5 is 1. Times 4 is 4. Subtract and get a 1. Bring down the 2. 4 divided into 12. Well, that's 3 times, and 3 times 4 is 12. So there's no remainder. So I get what? I get 13. And then if I add 1 to both sides, then that tells me that n is equal to 14. All right? So now we have everything to write our sum. So we know we're finding the sum s of 14. N is equal to 14. A sub 1 is 1 plus our a sub n was 53 and divided by 2. So we have s of 14 is equal to, well, I could say 2 into 14 is 7. That'll give me some smaller numbers to work with. And 53 plus 1 is just 54. And again, just like I told you before, split out the big numbers, guys. You don't have to pull out a calculator. Okay? And then do distributive properties. 7 times 0 is 0. 7 times 5 is 35. 7 times 4 is 28. So you get s of 14 is equal to 8. 5 plus 2 is 7. So 378. Okay? And then you're done. So you've got the sum. All right? So again, it's all about determining, do you have an arithmetic sequence? Write down the formula for the sum. Write down the information you need to do the calculation. In this case, we determined we have to know our n. So we had to calculate that using the explicit form of the equation. And in the explicit form, you simply plug in everything you know and calculate what you don't know. And then once you do that, you have everything that you need to do the sum. And that's it. Now, I do want to point out one more thing, summation notation. If you were asked to write this in summation notation, then you can certainly do so. In this case, if I'm going to sum up n number of terms, well, this is how I would write it. So for this particular sequence, which again, we know it's arithmetic, we've been working with it the whole lesson. But again, if this were a new one, I'd be checking it. But this is going to be s of n equals the sum from I equal 1 to n of a sub 1, which we know is 2, plus 5n. Okay? So guys, to write out this progression, let's say I wanted the sum. Oh, let me erase that. All right. Let's say I'm going to do a calculation with this. And I want to do s, we'll make it short, s of 3. So we want I equals 1 to 3 of 2 plus 5n. Guys, if you were asked to write the sequence produced by this or the series, then all you would do is plug in for the first term 2 plus 5 times 1 plus 2 plus 5 times 2 plus 2 plus 5 times 3. See, this 1, 2, and 3 are simply the I values. So you evaluate the expression in the sum at I equal to 1, ooh. Yeah, but guys, oh, this is bad notation. Sorry about that. See right there? I'm going to write it in a different color. That should be an I. Can you correct that in your notes? I need to switch back to a pen. See right there? That should be an I. Okay? That's just bad. All right. So anyways, we're going to write this out. Let's evaluate this. So we got 2 plus 5 times 1 is what? That's going to be 7 plus 2 plus 5 times 2 is 12 plus 2 plus 3 times 5 is 17. Okay? Guys, is that correct? Okay. I'm looking at that and I'm thinking that's not really correct. So I think Mr. Young made a typo. This should have been n minus 1, but that's okay. The Bible says he who hastens his footstep errs. So I guess when I type this up, I should have typed that in. So this should be the explicit form right there. And if I did the explicit, then it would give me the correct 2 plus 7 plus 12, because we would have used n minus 1. And then the sum itself is just what? 7 and 12 is 19, 20, 21. Okay. And that's it. So again, can you correct that in your notes? I totally botched that. And I really hope that my summary has the correct thing. So this right here is wrong also. But I hope you get the point. This is progressing by plugging in I equal 1, I equal 2, I equal 3, and then so on and so forth. So again, this should be right here, I minus 1. Okay. No problem. Moving on. Summary. An arithmetic sequence does progress according to a common difference D from a first term A sub 1. The recursive form is given by A sub n equals A sub n minus 1 plus D, okay? And then the sum of a finite number of terms, this is correct. This one, again, needed correcting. This should be A sub 1 plus n minus 1 times D, okay? And I apologize for that, guys. And I had cut and paste that formula, so... Anyways, I hope you guys enjoyed this lesson. I hope you got a lot out of it, and I hope you're very prepared to do your assignment for arithmetic sequences and series. And until next time, I'll talk with you later. Thank you very much, and have a great day.